Welcome to AI Arch Result. In this episode, I would like to talk about detection of fakeness of voices. So I was talking with Grok about how to use generative AI to find out if voice is AI generated. And after talkie, I have he created for me Python code to detect whether the voice is fake or not. And I tried it with two voices. One voice that was generated by very cheap TTS mp3.com service, very low quality, very cheap text-to-voice generator. And as I expected, the result is that it is AI generated 99%. However, I also uploaded a human voice. I took a podcast and I snatched from this podcast a couple seconds. Probably the length was very short. This is the reason. Just a couple seconds from a real podcast. And it was a real person for sure, because I know this person. And look, it also said that this voice is fake. So this shows that detection of fakeness of whether the given voice is AI generated or not is not a trivial task. So let's take a look at my discussion with Grok AI. I asked him how to use AI to find out if voice is AI generated. And he said that there are several methods. You can effectively use AI, also generating AI, but he said that most practical detectors use deep learning models. So, meaning neural networks trained on real versus synthetic audio examples. Deep learning means that it is not generative. This is the classical machine learning. But also, you can use multi-modal generative AI. So this video is not about going into detail, just a short overview. So number one, the quickest method to detect AI voice is using free or paid online AI voice generators. And as of now, the most popular ones are from 11 Labs, from detectors.com, and detectable.ar, and so on. So there are the AI voice detectors online. Then there is hybrid human and AI listening analysis. So because their AI voices nowadays are so good that they can even simulate different stuff. So, and it can be enhanced with Gen AI. So you can transcribe this using Whisper or ChatGPT voice or Claude. And you can ask a large language model the prompt, analyze this transcript and audio description for signs it might be AI generated or cloned speech. Look for unnatural phrasing, emotional consistency, or lack of human quirks. Nowadays, everything can be simulated. Okay, number three, the powerful creative method using spectrograms and multi-modal generative AI. So basically, you are converting the audio to a spectrogram, so they like the image of the frequencies, and then you upload it to the multi-modal generative AI that supports vision. And here are some examples listed, including ChatGPT, Claude, Gemini, and Grok. And then you use as a prompt. This is a spectrogram analyze for signs of AI speech. And this is how such spectrogram looks like here. Here's a picture. And analysis. And number four, the advanced developer options build or use stronger models. And do yourself model, like convert audio to the spectrogram images and train a CNN, so the neural network. And there's also state-of-the-art open source, which is audio anti-pushing using integrated spectrograph graph attention networks. And also Hugging Face has a lot of relation with mothers and mothers. So you can find on a Hugging Face by searching for audio defect detection or speech anti-pushing mothers. And here are her limitations. No tool is perfect. There are false positives, negatives, as you have seen in my demonstration in the beginning. Layer your defenses. So on my detector, manually scanning spectrogram, multi-modal AI. So layering of defections. High stakes errors. So if it is high stakes, then the enterprise solutions like pin drop or professional forensic services. And watermarking. So some generators are embedding detectable signals. And the comfort matters. Who created it, why, and metadata and source verification helps. So here's recommended workflow. And the reason I have to go into the details. But I also specifically asked the Grok AI whether there are solutions with local large language models without internet. And he says, yes. And the best for accuracy are specialized local audio deepfake detection models. And here's this AASIST assist. Special previously also Hugging Face. And so you can use them by installing Python and calling the stuff. Number 2 is local multi-modal large language models, like is a true generative AI approach, but using spectrogram and visual large language models. Because the large language models can see stuff, not just language, but also images. And the recommended setup is Stupid Llama. I don't like Llama, but there are other models, or Gamma. Gamma is much better. But anyways, then I asked, here's the summary of different approaches. But I asked at the end, Grok, give me a simple Python script for a Hugging Face, local defect auto model that will run in Google Colab, because I have Google Colab, which has GPUs, very powerful GPUs, and a lot of RAM, GPUs and RAM in PC. Sorry, this is a Linux, not PC, in the server, in Google Cloud. So I have Google Colab, so I have programmed it here based on this answer. So open Google Colab, download this defect detection, install, load the model, I did it, upload the file, I did it, run the detection, and I did it. But results were very disappointing because the real person was identified as a fake, 98%. So it was disappointing. The defection failed. If you want to test without uploading, there's also you can download, of course, with wget, because then you are downloading to the Linux of Google Colab virtual machine by using exclamation mark and Unix command, Linux command like wget. So you see, I did it, and it shows that this whole process is not easy, and it's tricky because particularly nowadays, first of all, there's false negatives, like my detection here. The person, real human, the native speaker for BSI was recognized as a fake AI, and also there are different ways: spectrogram, local vision, specialized audio model, and full privacy by using, for example, Olana. So thank you for watching. Please subscribe if you haven't yet, and give a like.